We are now starting on notebook 11, working with Pandas. For a long time, if you wanted to do any kind of data science workflows in Python, the only options were you read the file line by line, do all the data manipulation yourself, and it was not very pleasant, it was not very fun, and also it was not very fast. Python users often complain that when you scale your analysis to a very large data set, it becomes quite slow because reading files line by line is not very efficient. So over time, as Python became more popular for data science, a new library was developed called Pandas, which is custom built for the data science workflows. As GIS professionals, we are also data scientists. Our workflows are also very similar to the data science workflows. So if you're doing any geospatial analysis, Pandas will be your go-to choice for the package that you want to use to read and manipulate geospatial data. One of the key things that Pandas does is it's built on top of this another very popular library called NumPy, which is written in C++. That means all the operations they're doing are actually being carried out by C++, and they are very fast. And so you get very high performance, but it gives you this really nice API, which is very friendly and easy to work with data. So let's go through a brief presentation on what Panda is and learn some terminology. Let's learn about some Pandas basics. Pandas puts a restriction that the kind of data it works with is structured data and a tabular data. So this is a big restriction that Panda puts it, but just pause a moment and think about all the data that you ever worked with. Everything is tabular data, rows and columns. If you have CSV files, Excel files, they're all tabular data. You might say, oh, what about my GIS shapefiles? Well, that's just tabular data. It's attribute table, and the geometries can be represented just as another column. So your GIS shapefiles and vector data also becomes tabular data. Almost all the data we work with is tabular data. So Pandas is optimized to work with tabular data sets, and that means it becomes very simple and efficient, and it provides you with a very easy way to access those data sets. You can read from many structured data formats like CSV file, Excel files, HDF files, any kind of tabular data format that you can think of, Pandas will be able to read it. And it gives you built-in functions for doing all the data processing that analysts typically do. You want to do data cleaning. You read a file, I want to preview the file, I want to remove duplicates, I want to remove null values, and so on. I want to do this merge within the file, I want to remove certain rows, and all of this kind of data processing, you have built-in functions. So time series, again, Pandas has a lot of functions for time series processing, which you can use even with your geospatial data. You can even extract time series from remote sensing data and process it using Pandas, using the built-in functions. One of the things is you'll find this Pandas is very fast. So if you try to do some analysis using QGIS or ArcGIS, Pandas for the same workflow will be much more efficient, much more faster. So when we learn about this, you can compare, do the same thing in your GIS software. Pandas will be much faster in doing the same thing. And it's very simple. So as you'll see, the Pandas code looks very simple, and it makes doing data processing fun and efficient. In Pandas, when you're working with the data, you work with this object called data frame. A data frame is whenever you read a file, it becomes a data frame, rows and columns. Okay. So anything that is your data frame is basically row and columns. Series is your rows are represented as an object called series. Your columns are also represented as series. So in Pandas, when you're trying to do something, it'll say, run this function. This function runs on a data frame. This function runs on a series. A series is either a single row or a single column. A data frame is the whole thing. The rows and columns, everything is a data frame. So when you read the data that looks like this, you have some rows and some columns. This whole thing is called a data frame. And you can do something with it. A single row is a series, or a single column is a series. So data frame is made of multiple series for each row and each column. And depending on what you're doing, you can use the functions that are used for the data frame or series and do the analysis. All right, let's go back to the code and see how Pandas makes solving the same problem that is solved in the previous notebook, computing the distances between your home city to every other city. We'll work the same data and go to the same workflow, but this time we'll use Pandas. So first, we imported the environment that we are using. Honda comes built in with Pandas, so we don't have to install it. If you use any of the environment, or if you install Python from another method, you can go and install Pandas, and then you can import it. You can say import Pandas. So once it's installed, you can just run it. And if it's installed, it'll just run it without any errors. And that means Pandas is imported. Here we get a warning. This is just saying that in the future version, you will need some additional installations of Pandas. Right now, you can just ignore this. So I'm going to run it again, and you'll get the error that will go away. So typically, you import Pandas like this. There are a lot of functions when you're running Pandas. You'll have to say pandas.dataframe, pandas.series, pandas.this. So coders are lazy. They say, I don't want to type pandas.dataframe every time. So there's a shorthand that people use saying we import pandas as PD. That means instead of typing pandas.dataframe, I can say pd.dataframe. It just saves you a few characters. This is a convention. All the code you'll find on the internet will use this convention. So if you use the same convention, your code will just be simpler. And this is just a convention. You can say import pandas as X. That's also fine. And then you can say x.dataframe. Right? It's just a convention that people use. So we'll just stick to the convention and import pandas as PDs. Let's read the file. So we first define a path. And to read the file in Pandas, you pick an appropriate function. There are functions to read different formats. We have a CSV file. We can just say pd.readCSV and path. If you have an Excel file, you can say pd.readExcel. If you have a HDF file, you can say pd.HDF. And once you read any of the supported formats, you get a data frame. We'll save it into the data frame object. Let's run this. And done. This is it. No for loops, no open close files, no with statements, no read board, nothing. Pandas will mean everything for you. And let's take a look at the result. We can print this data frame. I can print this. If you are not in a Jupyter environment, you have to use print. If you are in a Jupyter environment, to see the result of any variable, to see the value of any variable, you can just type the variable name and Jupyter will display this. Then additional feature of Jupyter is because it's custom built for data science, all the pandas and GeoPandas objects will be rendered very nicely. So if you just omit the print statement, you'll see a much nicer preview of your result. So let's just see what this, we call this one line of code, pd.readCSV. This is a 15,000 line CSV. We read it, saved it into this variable. Let's see what's inside this variable. And that's what we get. Right? Pandas will say, oh, do you want to look at the first 5 rows, at the last 5 rows? Okay, sure, we do. So it just shows you by default. It shows you the preview for all the columns, rows, first 5 rows and last 5 rows. It also shows you the 11 columns here. So you don't, no counters, no break statements, nothing. You can just say, read this file, show me a preview, and you get your data. Right? So again, it kind of mimics the data science workflow that we have, and it gives you this nice format. Another advantage of working in a Jupyter environment is that it understands all of these formats. If you just did print, if you're on a terminal or in other environment, it'll print like this. It'll give you the same thing as a text, but if you just omit the print statement, Jupyter will just print it and format it nicely. So Jupyter, from now on, you can skip the print statements. I wanted to make sure you get used to writing print statements before, because otherwise, if you are not in Jupyter, you'll say, my code has an error. Why doesn't it work? Because if you have to print it explicitly in Jupyter, you can just type the name as a variable. So you'll print. There are some additional functions that it provides. If you want to know a little bit more about the data, you can say df.head. df.head will give you the first 5 rows by default. df.tail will give you the last 5 rows. You can also give, say, head 10. Give me the first 10 rows. So head will, you can specify the number of rows that you want. So it just give you a larger preview if you wanted to. There's an additional function called df.info. If you put it, you'll get some info about the data. You can say this is the column, this is the type of each column. It's using the total RAM, 1.3 megabytes, and you can have some more info about it. One of the reasons Pandas is very fast is because when you read a file using standard Python, you'll read the file line by line. And when you say do some processing, it's going to go through the entire file from your disk and then do something with it. Pandas will load the entire data in RAM. And RAM access is super fast. And also the way it organizes that in RAM is efficient for kind of the common lookups that you do. So that's why sometimes you read a file, you want to check how much RAM it's using. Right now, this one is using only 1.3 megabytes of RAM. If you're working with very large data, sometimes memory becomes a problem. So there are solutions around it in the Python ecosystem. I'll explain that a little later on. But one of the reasons Pandas is fast is because it loads everything to RAM. It organizes the data efficiently in RAM so you can access it faster, and all the implementation is in C++. When you work with a data frame, you have the data frame and you say, I want to now select the fifth row, or I want to get the second column, or I want to find some data that is, in a certain, matches certain conditions. So how do we select stuff in Pandas? And this is probably the biggest stumbling block for beginners. If you just started using Pandas and got some documentation, this part will be a little confusing. So that's why I want to cover it and explain to you. In Pandas, you have, when you read a data frame, all rows have an index. So when you see the data frame, you'll see that there is an index column that comes implicitly with each row. Indexing starts from 0. So you can say, I read a data frame, Pandas assigns an index starting from 0, from the first row all the way to the nth row. So we can say, I want the fifth row, you can say index 4. There's the index column comes to this. So all rows have an index. The columns have names. So columns also have an index, but they also have a label. Because in a tabular data structure, you typically don't have names for each row, right? But you have names for each column. So Pandas will assign whatever the name of the column is there. You can say, I want this particular column. You can say, give me col 3, the name of the column. Rows don't typically have name. You have to refer to rows by the index. There's an option in Pandas to say, oh, my rows actually have names. I want to assign one of the values of the columns as the row name. You can do that. But typically, when you read the data, you just say, I have first row, second row, third row. Each column have names. So remember, rows have indexes, columns have index and label. You typically refer to each row by its index, typically refer to each column by its label. Pandas have different functions to access stuff by index and access stuff by the labels. If you want to select any row or column by its index, you use this function called iloc. Iloc is index lookup or index locate. So you say, I want the first row, say, give me the row 0. You say, I want the first column, so give me the column 0. Okay, so iloc is the same as your indexing function. So you have used your list index or dictionary index. You can say row of 0 or list of 0, give the first one, list of 1, give this. In Pandas, because it's two-dimensional data, why Pandas had to invent its own function? Because what does index 0 mean? Well, it can mean 0th column or 0th row. So that's why you have the special function called iloc, which you can use the indexing notation with the square brackets. If you want to select stuff by label, say I have my column and I want to select it, you need to use locate, and you need to give the label for the row and column. Yeah, so loc and iloc are confusing for beginners. We'll go through many examples so you can get it. But remember, iloc, if you want to index stuff by the index, you use iloc. If you have a label for each column or row, you use loc. Let's see an example. I want to select the first row. I have a data frame. I want to select the first row. df.iloc of 0 will give you the first row. Simple enough. I want to select the first 5 row. Can anybody tell me what would be the syntax? iloc 0 to 5. So ignore the iloc part. It's the same indexing as other thing. Start at 0, stop at 5, stop before 5. So 0 to 5 will give you the first 5 rows. And the same indexing notation works. The third thing is the iteration. So now you have iloc, you can give rows and columns. So let's say I want to select all rows and the first 5 columns. This one is a bit trickier. How would you do this? Go back and say iloc and give row index and column index. So you can say, I want to select all rows and first 5 columns. How would we do this? What's the notation for selecting everything? Colon. You can say If you just give a blank colon, that means start at the beginning, end at the end. So you can say df ilog colon, comma, 0:5. So all rows and first 5 columns. Select every alternate row in reverse order. Well, same thing works. So ilog colon colon -2, same thing, same indexing thing that we learned earlier, works with pandas as well. Here, if you skip the second part, it just selects all columns. You don't have to specify it. Okay, so same indexing notation. Hopefully, it'll help you now get the relevant stuff that you need from your data frame. Let's see, select by label. I want to select the first column. The name of the column is col1. So I can say df.lock. So the difference between the previous one and this one is now we have label for the column. So we need to put in quotes and say df.lock colon all rows of col1 in quotes. Select the first and second column. Well, df.lock colon col1 col2. Give a list of columns and you'll select that. So if you say I have this data frame, I want to retain only these 2 columns in my output, you just do df.lock and select this. Since this one is very common, like you have to select the rows or refer to, but select columns or list of columns very commonly. Instead of typing this whole thing, Pandas gives you a shorthand. So you can do the same thing. Saying df of col1 is same as df.lock all rows column 1 or df of list of columns. Right? So this 2 are the shorthand for this one. If you want to select all rows in column 1, do this. If you say I want first 5 rows in column 1, well, you can just use other syntax. But this exists because you need to do it quite commonly. Let's learn one more thing about filtering data. How do we select a subset of data from Pandas? The syntax for doing this is you can say, I want to apply a condition and select certain data. So I have to say, I have this data representing the entire world. I want to select data only for this country. So how do you apply the filter? You can say df of condition. This is the standard syntax. So you can say, find all rows where column 1 is greater than 10. So you can say df. So this is the syntax. So you said from df, and this is your condition. So df of col1 greater than 10. So this condition will return true or false for every row. If the first row is true, it'll select that. The second row is false, it'll not select that. So this can be a bit confusing, but the way to think about this is you say apply this condition on df. Inside the square brackets is your condition. So you say df of col1 greater than 10. That's one of the conditions. You can select that. What about this one? df of col1 not equals x. So you'll find all rows where column 1 is not x. If you want multiple conditions, it says df of col1 is x and df of col2 is y. And you can put all those 2 conditions inside the square bracket and run it on the df one. And it'll select that. You'll use this quite a bit in doing the data processing. This is very similar to applying a filter in QGIS or ArcGIS. You have your data and say, filter this attribute table where the column 1 equals this. And it will only work with that particular subset of the data. Pandas also has string matching things. You can say, I want to say if the column name begins with this, or the first 5 letters of the column is something like this. So you can do something like this. df of col1 dot str dot starts with a. So str allows you to work with the column values or row values as strings, and then say, if it starts with a, select that. And there are a bunch of functions you can run with the str functions. So many times in GIS, you might be saying, I want all rows that starts with nh. So you'll say df.col1.sh.str.starts with nh, and it picks up that. You can also use regular expressions and find stuff that matches a pattern and so on. You can also match a list. So, col1 is in A or B. So you can specify a list of values that will match from. And again, there are a bunch of other functions that you can filter for null values, duplicates, etc. When you're finding yourself saying that, how do I do this? The right keywords to search for, how to filter Pandas data frame for this. And then you'll find the right function to do this. Pandas is such a vast library. Even today, when I'm working on some projects, I often find myself, how do I do this? And if you put the right keywords, you'll find the Pandas function and you'll be able to do this. And Pandas has many, many functions that are built in. So it's unlikely that when you're stuck with a problem, you have to implement your own. Rightly, there's a function already there, which is optimized, and you can just run it to either reformat your data or select a subset of the data that you want to do. Okay. Let's see some examples in the code. It will become more clear. We saw an example of filtering and selecting data. Let's apply the filter. Remember the problem we were working with? We want to find the distance from a home city to every other city in the country. So let's say I have this data frame. Let's just see an example of a data frame. I have my data frame. I want to select all rows where the country is a specific country. So if I want to apply a condition, this is the syntax, right? df of some condition. So let's write the condition. I can say if df of country, so this is the way to refer to the country column, equals Japan. And you can see, I can see 75 matches and only the Japan cities. You can also see it's very fast because Pandas can do this kind of operation very, very fast and show the result immediately. When you do this, you need to save the output in some other data frame. So, right now we can just say output is this, and then we can show the output. Yeah, so this is one way to work with that. Let's do one more example. Let's say we want to filter the data frame to show all cities with population greater than, say, 1 million. How do we do this? How do we change this condition? I want to see all the large cities. What would be my condition here? So the condition is we want to check the population column greater than this value. How do we refer to the population column? We can say df of population. So this is how we select the column. So this population greater than this number. And you can see these are all the 498 cities which have population more than this number. We can combine multiple conditions. So let's say we want to see all the cities in India. So now we want to add two conditions, large cities in India. The way to do this is we can write another condition. So we can say df of country equals India. Right? So we have two conditions. To combine them, we need to put this AND operator. So this, and we need to put this in parentheses. So this is the first condition. This is the second condition. So this says check where population is greater than this million, country is India. And now we have all the cities in India which match this condition. Right? So it's just very similar to working with Excel or an attribute query that you do in your GIS. Maybe I'll give you one more challenge. Filter the data frame to show all cities in the northern hemisphere. How do I do this? I want to show all the cities in the northern hemisphere. Northern hemisphere is above equator. So all the cities where latitude is greater than 0. So we'll say filter to all rows where lat is greater than 0. And these are all the northern hemisphere cities. If you do less than 0, these are all southern hemisphere cities. So again, filtering works very similar. Have a condition, apply on data frame, and you can get the condition. So let's do this thing that we set out to do. We first want to extract the coordinates of our home city. So let's define our home city. So I'll say my home city is Bengaluru, and I want to filter it for the home city. So we'll say my df, and we'll apply the filter. We'll say my df of city. We're going to use the city ASCII column. There are two representations of city. There is a UTF-8 version and the ASCII version. So ASCII version is just easier to manage. So we'll just say this, it comes out home city. So you can see I've just selected my home city. What is the type of this object that we got? We just filtered it to this home city. What is the type of object we got? We filtered a data frame. When you filter a data frame, you get a data frame. Though it looks like there's only one row, we still have a data frame. So how do we get the first row as a separate object? I want to extract the lat long of this. So I want to just get the first row out of this data frame. How do we access the first row of a data frame? Go back to the iloc and lock. How do we access the first row of a data frame? What function would we use? So we have this data frame with one row. We just want to get the first row out. We can say iloc of 0. And this will give me the first row of this data frame. This looks different. What is this object? Is it a data frame? Let's check. So if we just say, what is the type of the original one? When we filtered it, it's the data frame. When we did the iloc of 0, it just gave us one row. So that's a series. Yeah. So each data frame is made out of multiple series for each row and each column. So we have iloc 0. We now have this data for this row, and we can then extract it and saying, I want the lat of this. So let us say this is my city, and I can say print city of lat and city of long. And I can just extract that value. So I had a whole data frame. I filtered it, extracted the result into a series, and access the value of that particular rows, 2 columns from that row. And now we have the home city's coordinate. So again, we go through the workflow. If you go run the cells in your notebook, you'll see it goes to the workflow. It home countries notified. Okay, so we run this, and what we do is we want to filter it to a country first, and we run this copy function. This function is useful where you say I'm applying some filter, and I want to then later change the data frame. I want to delete some rows, I want to delete some columns, etc. When you apply a filter, you cannot manipulate or add stuff to the data frame because you are only seeing, like, say 100 rows out of 1,000 rows. You can't add column only to those 100 rows. So when you have a filtered view, you are restricted sometimes to adding columns or deleting columns. That's why we just make a copy of it, save it to a new data frame, and then we can just extract the home city coordinates. Right. So now we go through and we now have extracted the home city coordinates. So that was the first part. We learned about lock and iloc. We learned about filtering. We selected all the cities from a particular country, created a new data frame, selected a home city coordinates by applying a filter, selecting the row, and then extracting those out as 2 numbers. So we have our home city coordinates, and now we are ready to do the calculation and compute the distance from our home city to every other city in the country. Next step, we want to compute a new column. Think back to how you do data analysis in Excel. If you want to add a new column to your spreadsheet, you don't say, I will iterate through each row, take some data, add a new column, and write it into my disk. The way you think about the problem is, what's the formula for adding a new column? You write that formula and you drag that through all the cells. Right? That's how data scientists think, and that's how we do the data processing. Think about in a GIS, how do we add a new column to your attribute table? Well, we run a function which says, let's apply an expression that will go and add a new column. So Pandas works the same way. When you want to add a new column with some computation, you define what you want to do and apply it on all the rows. If you have a simple column, you say, I want a new column, which is the multiplying one column by 10 times, just say df.col1 times 10. And this works across all the rows. So these are called vector operations. That means when you say times 10 divided by 2, it just goes through the entire data frame. This is very efficient for the entire, very large data sets. In Pandas, if you find yourself doing for loops, that means you are doing something wrong. For loops will run operations of one row at a time and it'll be slow. You have built-in functions that do this vectorized operations across the entire data frame, across the entire columns, very, very fast. So you should be using methods like this. If you want to say column 3 is column 1 plus column 2, just do this and it'll work across the rows. You can also do sum round. You have all this function that will just say, if say df call one round, it'll just round off all the values in column 1 and give you a new column. Right? So you have all these functions for doing kind of simple statistics. What I want to teach you mainly is this function where you say, I want to apply a formula and compute a new column. That is this function called apply. You should not be writing any for loops. This is very intuitive to any other programmers. If you've done programming in other languages, you'll come to Pandas and say, oh, I want to add a new column. I'll iterate through each row and do something. Do not do this. To have the most efficient workflow in Pandas, you use the apply function and say df.apply, write a function that takes one row or one column and processes it. Let's see how it works. In your tabular data, you can think of your data to have two dimensions. One is this axis 0, which is going down this way. Axis 1 is going this way. Burn this diagram in your head. This will help you when you work with Pandas and GeoPandas. Many functions will ask you along what axis do you want to apply this computation. If you say axis 1, it'll add a new column. So if you say axis 1, it'll go through each row, add a new column. If you say axis row, it'll go through each row and add a new row at the bottom. Most of the GIS operations will add new columns. You rarely do any operations which adds a new row to your data, like summarizing each row. You typically add a new column. So if you're confused, you can use axis 1 by default. That will represent a lot of your GIS operations. So you write a function and you can run it and say, I want to run this function along axis 1. It'll run on each row and it'll compute a new column. You say along axis 0, it'll work on each column and give you a new row. Let's see this in action. So far we have our data frame. We have filtered it to this specific country. I have a country DF, which contains all the cities in a country, 212 rows for cities in India. Now what I want to do is I want to add a new column here, which is the distance from my home city to this particular city. So I want to add a new column. What's the distance from this city to my home city? I would say, how do I define the computation function? Given a row, how would I process it? So I would write a function like this. So I write a function called calculate distance. It takes a row. For each row, we'll extract the lat and long of that particular row. Once we have the coordinates, we can just say, use GeoPy and give me the geodesic distance between that city's coordinate and my home city coordinates in kilometers. And that's it. So this function will take each row, return a number, which is the distance between that city and the home city in kilometers. That's it. This is your formula that you want to apply. How do we run it on our data frame? So we say my country data frame dot apply. Apply this function, calculate distance. Which axis do we apply? We apply it on axis 1 because we want to add a new column to it. That's it. This will run this function on all rows and you'll get the result. We say this is a new column. So let's just save it into a new column. I'll just say save the results into a new column in my country DF, which is the data frame. And as a new column distance. Let's see what happened. You can see we have a new column in the data frame and we have the distances. No for loops. You just write a function, apply it, and suddenly you have a new column. And this workflow makes it the code so much simpler, and your workflow also very fast. When you work on your projects, you'll be writing a function and applying it. That's will be a very common thing that you'll do when you're doing data processing. So understanding this workflow is very important. When you run this apply function on axis 1, the input to the function is each row. That's why you say my function will expect a row of a data frame. What do I do with the row? You can extract certain values and do the processing and always return whatever you want to return, and then it'll become a new column. Okay, so we have our nice data frame, and so we are ready to save this to disk, but I don't want all this column. So let's select only the city ASCII and distance column. What do? How do I select only these two columns, the city ASCII and distance column from this data frame? Think back to the presentation. What function would I use to select those two columns? If you want to select certain columns, we can do this df.block : and the list of columns, or we can do the shortcut df and list of columns, and you'll only select those two columns. Okay, let's see how this works. So we can say df, give a list of columns, we'll do city ASCII and distance. Or not df, country df. Okay, so you can see now I selected these two columns. Maybe I want to rename this column to something different. Okay, you don't need to remember the function name. You can just say, how do I rename a column in a Pandas data frame? And you'll say the call function is called rename. And this is a syntax. It'll just say, keep the columns. You can give the mapping between the old and new columns. So it says city ASCII becomes city. So we just renamed this. Now we rename the column. Nice. Let's save it to disk. Remember, how did we save it to disk using CSV file? Dict, writer, iterate, nothing. So similar to how we read a file using Pandas, we simply define the name of the path of the file and can just write that. So let's first define an output path. So let's say we want to write this to the output here, output/distance pandas.csv, and we have our final data frame filtered. It's a filtered dot to CSV. So read CSV will read it to CSV, will take a data frame and write it to a CSV file. Done. And output, we can see this is my output. So we saved this to the file. We have a CSV file. But again, you can see there's an extra column here. Can anybody tell me what is this column that came in? We didn't ask this column. Why did we get an extra column? So this is the index. You can see Pandas keeps track of the index is the first column. It's useful to keep it around when you're doing analysis, but you don't want it in a file. So we can just say, yeah, I don't want this. So there's an option here, say index was false. And now we don't have that. If you want to change this and save it to an Excel file, it's just as simple as to Excel. Take a data frame, and now you get an Excel file. So you just use the same function and say, so to CSV, you can do to Excel or to any other supported format. It makes it quite easy to say, I have a common object like a data frame, can write to any format that is supported. And the same kind of concept continues to GeoPandas, where we can take a geo data frame and save it to shapefile or type file or geodescriptor, any of the supported formats, because essentially it's just a tabular data that we want to structure it as a specific format. Right, we're done. We need to do an exercise.